Dear learners, in this session, we will introduce the idea of derivatives. Derivative is defined as the instantaneous rate of change of a function at a point at a specific point. When we find the derivative of a function f, it gives us the gradient at the point, denoted by dy dx or f prime at x. By definition, we say that the derivative of the function f at x is giving us the limit of the function days as s approaches 0, and this is known as the differentiation from the first principle or by definition. So today we are going to use this first principle to find the derivative of certain functions. So let's take the first example. So we have the first example. Using the first principle or by definition, find f prime at x. That is the derivative of the function f at x is equal to 2x minus 5. So this is a linear function. You can see it. The gradient is 2. But with this one, we are going to use the definition formula to find the gradient. So what we are going to do is, if we write our f at x, and then we also find our f x plus h, and then we substitute back into this formula, and then we do our normal simplification. So first thing, we know that our f at x is equal to 2x minus 5, and then we find f at x plus h, which means that wherever you see x, you substitute x plus h there. So we are going to get 2 brackets x plus h and then minus 5. Now we know this, we can come and substitute it back into the formula. So we know that f prime at x is equal to, that's, we have the limit as h approaches 0 of f at x plus h minus f at x all over h. Now f at x plus h is what? Is 2x plus h minus 5, and then f at s is minus 2x minus 5 all over h. You have to bring the limit as h approaches 0. So let's continue. We are going to get the limit as h approaches 0. Let's expand. We are going to get 2x plus 2h minus 5, and then minus 2x plus 5 all over h. So we can see that positive 2x and then minus 2x will go away. So we are left with the limit as h approaches 0 of 2h, and then this 5 and this 5 will go. So we are left with that. So when we take the limit all over h as h approaches 0, so from when we take the limit, we are going to get 0. So we can factorize our h out, so that we'll be left with 2 all over h, so that the h and h will go. We'll be left with the limit as h approaches 0 of 2, and we know that the limit of a constant is still the constant, and this is the derivative as I said earlier. Let's take the next example. We have to find the derivative of s squared using the first principle. So we first have to find our f at x plus h, and this is going to give us x plus h all squared. So we substitute into the formula the limit as h approaches 0 of f at x plus h is x plus h all squared minus f at x, which is what? S squared all over h. Now when we expand this, we are going to get s squared plus 2xh plus h squared, then minus x squared all over h. So you can see that s squared and s squared will go. We are left with the limit as h approaches 0 of 2xh plus h squared all over h. So from here, we can factorize our h out, so that we'll be left with 2x plus h all over h, so that this h and this h will go away. We are left with the limit as h approaches 0 of 2x plus h. Now when we take the limit from here, we are going to get the limit as h approaches 0 of 2x plus the limit as h approaches 0 of h, and this will give us 2x and this will give us 0. Therefore, the gradient function is 2x. Let's take another example. Assuming you are being asked to find the derivative of this function using the first principle, so we write our f at x is equal to root of x, and then f at x plus h will give us x plus h. So we come back and write the formula, and then we substitute them into it. So this is going to give us root of x plus h minus root of x all over h. From here, when we take the limit, we'll be getting 0 over 0. So what we are going to do is that we find the conjugate of the numerator, and then we multiply it by the numerator and then the denominator. In other words, we rationalize the function with respect to the numerator. Now when you rationalize this function with respect to the numerator, you are going to get times the conjugate of the numerator is x plus h plus root of x all over root of x plus h plus root of x. So after that, you do your normal simplification. So we have the limit as h approaches 0. Now this is difference of two squares. This and that is difference of two squares. So we square this, we square that. We are done with the numerator. So we are going to get root of x plus h all squared minus root of x all squared. Then we have h times root of x plus h plus root of x. So we have the limit as h approaches 0. This is giving us x plus h minus x all over h bracket root of x plus h plus root of x. We can see that minus s and positive s will go away. You'll be left with the limit as h approaches 0 of h all over h out root of x plus h plus root of x. Now you can see that h and h will go away. We are now left with the limit as h approaches 0 of 1 all over root of x plus h plus root of x. Now when we take the limit, we are going to get 1 over root of x plus 0 plus root of x. And this is giving us 1 over root of x plus root of x. And at the end, we are getting 1 over 2 root of x, and this is the gradient function of this function. How would you find the gradient of this function using the first principle? So we write our f at x, which is equal to s cubed minus x, and then we write our f at x plus h, which is going to give us x plus h all cubed minus x plus h, and then after that we substitute it into the formula. So we have x plus h all cubed minus x plus h minus f at x, which is s cubed minus x all over h. So we are going to get the limit. Now when we expand this, we are going to get x cubed plus 3xh plus 3xh squared plus h cubed. And when you expand this, you are getting minus x minus h, and this will also give you minus s cubed plus x all over h. So you have the limit as h approaches 0 of, you can see that positive s cubed minus s cubed, we have negative x, positive x. I think we are done with the cancellation. So we are left with the limit as h approaches 0 of 3x squared plus h plus 3x h squared plus h cubed minus h all over h. Now, if we are to take the limit, we will get 0. So let's factorize h out. We'll be left with 3x squared plus 3xh plus h squared minus 1 all over h. So this h and this h will go. Now from here, we have the limit as h approaches 0 of 3x squared plus 3xh plus h squared minus 1. Now when we take the limit of this, we are going to get 3x squared. This will round to 0. This will also round to 0. And the limit of a constant is a constant. So we have 3x squared minus 1. And this is the derivative of this function. You can try your hands on this. The function 1 over x, we have to find f prime at x using the first principle. Now the suggested answer is f prime at x is equal to minus 1 over x squared. Follow the same process method to see if you can get up to this very answer. Thanks for watching. Make sure you subscribe to this very channel for more updates.